It is not a secret that I believe in Kubernetes, and that I think that it is much more than a thingy where we run containers. It is an extensible API with controllers that can manage any type of resources. It is a control plane for everything. That's why a while ago I was very excited when AWS Controllers for Kubernetes, better known as ACK project, was born. It allows us to extend Kubernetes with custom resource definitions and controllers that allow us to manage AWS resources through Kubernetes. It's awesome. Now, to be honest, I never liked the idea of having tools provided by cloud or hyperscaler vendors to manage their resources. I never liked AWS CloudFormation or Azure Bicep for a very, very simple reason. Those are limited to the hyperscaler that released them, and we are almost never doing everything in a single hyperscaler or cloud provider. There are always other services we might be using, so I never liked the idea that I would manage some resources with CloudFormation, others with Bicep, something else for Grafana, and let's say Datadog, what's or not for GitHub, Helm for Kubernetes, and so on and so forth. That's why Terraform was so great back in the day before we got Kubernetes. It's not great anymore, but it was great. It was a vendor-neutral way to manage any type of resources anywhere. That changed with Kubernetes. Now it does not matter that we might be using it to manage apps with Knative, clusters with ACK, databases with CMPG, and so on and so forth. Those are all CRDs and controllers that follow the same guidelines. They all feel and behave in a similar way because they are all standardized on Kubernetes API, and they all work seamlessly with the rest of the ecosystem. We'll take a quick break for me to introduce you to Korbit, the sponsor of this video. Korbit is an AI-powered code review agent that transforms your SDLC by delivering immediate, context-aware feedback on every single pull request. It performs like a senior engineer, but it is faster, like way faster. For engineers, it integrates with GitHub, Bitbucket, and GitLab. It detects bugs, security issues, and code quality concerns while educating developers with clear, actionable explanations. For managers, on the other hand, it generates release notes, sprint reviews, and performance insights automatically. Korbit supercharges developers, liberates reviewers, and gives engineering leaders the visibility they need to ship better code faster. More importantly, Korbit does not replace engineers. It upskills them. It makes them more productive. Big thanks to Korbit AI for sponsoring this video, and now let's get back to the main subject. All in all, having Kubernetes controllers provided by different vendors independently of each other is not only great, but very welcome. That's why ACK, when it arrived a few years ago, was exciting. The bad news is that back then it was too green. It had very low coverage, too many expected features were missing, and it did not work well. So I put it on hold until today. Most of controllers are now GA. Many of them are, at least according to AWS, stable and production ready. So I decided to go back to it and check it out. I wanted to see whether it is everything I hoped it would be. More importantly, I wanted to see whether I can switch to it and replace the controllers I am currently using. So today we will explore ACK and try to figure out whether you should ditch whichever tool and format you're using to manage resources in AWS. After all, if it works well and if AWS stands behind it, why wouldn't you use ACK as a building block of your control plane? With drift detection and reconciliation, the ability to wrap it into your own controllers, integration with Argo CD, Flux, Caverno, and other projects in the Kubernetes ecosystem, ACK is a very, very strong candidate to be just what we need to build parts of an internal developer platform related to AWS. It's not all we need, but it could be a very, very important piece of the puzzle. It's awesome, at least on paper, and I'm very excited. Let's get going. Let's see it in action. If you would like to manage AWS resources through Kubernetes, ACK seems to be the way to go. After all, AWS would not create it and maintain it if they don't believe in it. As a matter of fact, Having projects like ACK done by AWS itself is a validation that Kubernetes itself expanded way beyond a thingy that can run containers. Kubernetes is a control plane we can use to manage any type of resources, no matter where they are, and ACK could be a very important part of that story. So we can head out to services section of the documentation and see all groups and services we can manage. There is, for example, EC2 and RDS, which we'll use today. Both are released and both are generally available. So both are production ready, according to AWS. Now, I will not bore you with the installation of ACK controllers. All we have to do is install a Helm chart and then go through the pain of setting up IRSA. If we survive IRSA nightmare, we get CRDs that represent specific groups of services in AWS. So, to streamline that process and avoid boring you to death with the installation and setup, I already did all that. And now my EKS cluster has the ACK controllers for EC2 and RDS. We can observe what we got by retrieving all CRDs and filtering the output with Kates.aws, which is the API they all use. There can be two reactions to that list of EC2 and RDS CRDs. One could be, wow, now I can manage EC2 instances and VPCs and RDS DB instances and other resources in AWS. That's one reaction. That's the positive reaction based on prospects of using Kubernetes as a control plane to manage your stuff, no matter where that stuff is. That's the reaction of optimism, of a person who uses only the most common AWS services. Another reaction could be, what the is that it? Where are the rest of AWS services? Where are they? There are around 250, and I repeat, 250 API endpoints for AWS EC2 and RDS services, while ACK gives us around 30. That means that the current coverage is slightly above 10%. That does not look good, especially considering that ACK has been released more than 3 years ago. And for example, EC2 controller is currently version 1.4, meaning that it reached the stability usually associated with projects that pass from version 0 something to version 1. ACK is not a kid anymore, yet it provides abysmally low coverage of AWS services. Nevertheless, that is not necessarily a bad thing. Chances are that the CRDs ACK offers do cover what you need. If that's the case, my rant about the coverage is silly. It's all good. Who cares if what is missing is not what you need? So, I'll make a pause here. Think about something positive like rainbows and unicorns, happy thoughts. Okay, now I'm back. Let's say that we would like to run an RDS PostgreSQL database server. Since this is AWS, nothing is straightforward and we need to create quite a few resources to get the database server itself. Here's an example of all the resources we might need. We can see that all the resources we might need to run RDS in AWS are there. We have VPC, an internet gateway, a route table, a security group, few subnets, DB subnet group, and finally DB instance. If you focus on DB instance, which represents the actual RDS database server, we can see that all the fields we might normally have to specify are there. There are DB subnet group ref and VPC security group refs, which reference other resources in that manifest. There are also typical fields like the engine, whether it should be publicly accessible, allocated storage, and so on and so forth. As a matter of fact, if you ignore that we are looking at YAML, you might mistake that definition with Terraform, Pulumi, Ansible, CloudFormation, or any other tool you might be currently using to manage resources. That's normal, since all those tools, including ACK, are communicating with AWS API, and as such, their schemas are more or less matching the schemas of that same API. This, however, is different from those other tools because it is Kubernetes-native, meaning that we get all the good things we get from Kubernetes, be it drift detection, reconciliation, or anything else. Similarly, we can combine ACK with any tool we might be using in Kubernetes, meaning that we can manage it with Argo CD or Flux, package it all up into a Helm chart. But you can do it wrap it up into CRO or cross-plane compositions, apply policies with Kubernetes validating admission policy or Caverno, and so on and so forth. You must know why Kubernetes is awesome and how powerful its ecosystem is, so I won't waste your time justifying why using Kubernetes CRDs and controllers is a good thing. It is. Finally, there are a few field export resources which, unlike others, might not be as intuitive and easy to figure out. I'll get to those later. Since I did not set up Argo CD or Flux, we'll apply those resources directly with kubectl. Okay, so far, so good. More or less. Let's see whether we can observe what's going on. Here's the problem though. I would really like to be able to retrieve all the resources managed by ACK or all the resources somehow related to AWS. I would really like to know what is running in that namespace, at least when ACK is concerned. That, however, is not possible, or at least I do not know how to do it. There is no ACK or AWS or any other similar alias. So to retrieve all those, we need to execute something like kubectl namespace ateam get and start writing each of them separately. To make things even more complicated, there could be multiple resources with the same kind, so we might have to use full APIs. That was painful, and I honestly do not understand why AWS did not add aliases like AWS to all ACK controllers and something like EC2 to all the resources of the EC2 controllers. Nevertheless, we got the list of all those, and we are now faced with yet another disappointment. I would expect each of those resources to print some useful information besides the ID and the status. It would be nice to see the region where that VPC is running, or the address through which we could access the DB instance, or any other useful information. None of that is there. It seems that ACK controllers are all generic, and that's disappointing. Hopefully we'll see the info we might need if we describe any of those resources. We'll check on that later. Now, not only that print columns are generic, but even the few fields that always appear are somehow random. Some resources have the state, while others have the status, which probably serves the same purpose. Maybe the team working on the EC2 controller never coordinated with the team working on the RDS controller. Maybe that's the case. Who knows? To make things even worse, the state is not really working either. There is no value for the mydbx subnet. I reckon that I made some mistake, and that's fine. We all mess it up from time to time. Still, I would expect that mistake to be somehow reflected in the state column. Heck, for all I know, it's working perfectly, just as the security group might work perfectly without any state or status. Okay, now let's see whether we can figure out what's wrong, if anything, with that subnet by describing the resource. This is a good news, bad news situation. Since I'm still in the good mood and full of happy thoughts, I'll start with good news. We can see what's wrong. The availability zone is invalid, and I should have used one of the zones that are listed over there. Now I know what I did wrong, and that's great. That's great news. As for the bad news, ACK does not adhere to any sort of a standard. There is no ready condition typically present in most Kubernetes resources, be it those baked into Kubernetes or those coming from custom controllers. Now you might say that ACK is special and should not follow Kubernetes standards. That would be a silly thing to say, but let's roll with that one. The conditions between different ACK resources are not standardized either. They're all over the place. And whatever we learn by observing the conditions in that subnet will be different from conditions in other resources. That's not all bad news though. There is more. There are no events, so we do not know what the controller did. How is that possible? How could someone design a controller and forget to record events? Or if that was a conscious decision, how did anyone come to the conclusion that events are useless? I hope it's the former, so I will have to check who the contributors are in hope that they are all my age or older, because being over 50 gives us the advantage of being able to use, oh, I forgot, my memory is not as good as it was before. It's kind of an excuse that gets us out of quite a few situations. So I hope that they forgot about events instead of making that a conscious decision. So all people. Here's another example of a mess related to statuses and conditions and events. Besides the fact that there are no events, I dare you to find the status of that DB instance. Is it working or not? If it is, what is happening to it? Go ahead, find it. It is in the DB instance status field. That's the one that tells us what's going on. The information is there. We just need to try not to give up looking for it. Now, let's wait until DB instance is fully available before we take a look at a few other features of ACK. There we go. It is now available and we can turn our attention to the features we expect all Kubernetes resources to have. All of them. One of the features we expect from any Kubernetes resource is drift detection and reconciliation. I expect every single controller in Kubernetes to detect drifts between the desired and the actual state and to do reconciliation if a drift is detected. Let's see whether that is the case with ACK. I'm going to simulate a disaster scenario by going to AWS console and delete the RDS instance. The status that you see in the console clearly says that it is deleting it, right? Memorize it. That's what it's saying. Now, the logical outcome should be that the controller detected the change of the actual state and, to begin with, changed the state in the custom resource as well, right? Let's double check that. Okay. I was probably too hasty. Drift detection loop might be set to 1 minute or something similar. So let's wait a while longer. Let's fast forward a minute or so. ACK still claims that the instance is available, even though we saw that it is not. It's not. We saw the message, right? And that's bad, like really bad. Imagine that you did not saw me deleting that instance from the console and that you are monitoring the state of the system through those custom resources directly or through Grafana or anything else. You would rightfully conclude that everything works as expected until you start receiving phone calls from people complaining that everything went to hell. One possible explanation is that get command does not give us the information we might need. So let's describe that resource. That should surely give us a clue that something is wrong, right? Look at that. Oh, I cannot believe it. According to status conditions, everything is probably okay. We already saw that those are mostly useless, so I will ignore those. We can also see that the DB instance status is available, so it must be working as expected, right? Events are silent, so it is almost certainly working as expected. And the only conclusion I can make is that I did not delete it from the console. There are only two possible explanations. Either I was hallucinating, or the controller does not provide drift detection. Actually, there is a third explanation, which in my opinion is worse than the other two. Worse. By default, all ACK controllers attempt to detect drift once every 10 hours. That was a direct quote from the documentation. Honestly, I would prefer hallucination. If only those three options are given to me, hallucinations sound like the preferable one, with someone forgot to include drift detection in the controllers being the second. It makes much more sense to forget to do something than to make a conscious decision to make default drift detection set to 10 hours. Imagine the situation in which your system detects that the database is not working 10 hours after it actually became unavailable. How silly would that be? I expect every project to have sensible defaults, and I don't see why ACK should be an exception. I understand that drift detection loop of only a couple of seconds could put too much stress on AWS API. It would be okay if it's once a minute, or once every 5 minutes, or maybe even once every 10 minutes. Drift detection set to every 10 hours does not make any sense as the default value. Now, it could be worse. It could have been hard-coded to 10 hours. Fortunately, it's not, and we can change the default resync period. So let's set it to 60 seconds, which might be the other extreme, which I might not recommend in production, but should be okay to check whether it even works. Okay, let's see whether the change in the resync period will result in the change of the status. Okay, I'm watching, it's still available. Okay, let's fast forward 1 minute just to give it some time and look at that. Even after waiting for over a minute, the status is still available. So let me wait some more. Let's just look at it in silence, or even better, fast forward maybe. Okay, now we're talking. After a while, the status changed to creating, and that might only increase the confusion. Here's what's happening. ACK does not really track statuses. It had no idea that the instance status changed to deleting. It was oblivious, completely oblivious what's going on. Since it takes quite some time until AWS actually deletes the instance, it was claiming that it was available all that time. But once the instance was fully removed, the controller detected that the DB does not exist anymore and started creating a new one. That's when we saw the status change to creating. Now, since this is public, I need to choose my words carefully. I cannot say that the experience is shit, nor that it's nor use any of the words I would use among friends. Hence, I will say that the experience is disappointing. Still, we go to the database we are trying to create, and drift detection reconciliation is working sometimes, somehow, maybe, who knows. Even though the experience is disappointing, it is still better than if you try to do the same without the controllers. Kubernetes is the way to go, and having controllers like those from ACK is a good thing. Now, we're not yet done though. We still need to figure out how to connect our application to that database, and to do that, we need to fetch credentials. Very often we need some type of credentials to access AWS services. Databases are a good example. We often create them so that applications can store and access data, and to do that, apps need credentials. Typically, I'd expect to see something like secret.name and secret.namespace fields in the spec of specific resources, and if those are set, I would expect it to create that secret with whatever is needed to connect to the service. That's not much to ask, and that's a pattern used by quite a few controllers. Now, when it comes to credentials, we have yet another good news, bad news type of the situation. The bad news is that ACK does not have a built-in mechanism to store credentials related to resources we are managing. There is no option to specify in, let's say, DB instance, the name and the namespace where it should store IP, port, username, and password inside a secret that could later on be mounted to whichever application needs that secret. The good news is that there is a mechanism to do that. It requires more work than I would expect, but it's there. And here's an example. We are using field export resource that is installed with all ACK controllers to fetch master username from DB instance and put it into username field of the MyDB secret. Then we are doing a similar process with the endpoint and port. We're not retrieving passwords since RDS requires us to have it in a secret, which happens to be the same that we are extending, and I created it during the setup. Anyways, in that example, all the data is coming from the same resource, but if needed, we could have assembled data from multiple resources as well. Field export is flexible. It allows us to generate secrets, config maps, and probably other resources using data from other sources. It's simple and good at the same time. I like it. Still, it could be much easier to simply say, you know what data you're generating, right? Don't make me spell it out for you. Just put it into that secret. Nevertheless, what matters is that we are able to create secrets with the information needed to connect to resources in AWS, so it is a story with happy ending. We can confirm that it's all working by retrieving the secret MyDB from the cluster. And there we go. We can see that the endpoint, port, and username were added to the secret, so it can be mounted to whichever app should connect to the database. And now, all that's left is to see what to do with all those resources. More often than not, we do not keep a bunch of Kubernetes resources as endless lines of YAML in a file. Instead, we tend to wrap them into something more meaningful. For some, that something would be Helm, that would have all those resources as templates and expose parts that matter as values. We won't do that today for two reasons. First, if I show you an example with Helm, my face would turn red, and I could not resist explaining yet again why Helm is a bad option for anything but third-party operators. The second reason is that ACK is all about using custom resource definitions and controllers to manage resources, so it's only natural that we create our own CRDs if we would like to move into higher level abstractions. It makes sense. However, since we are focused on Kubernetes custom resource definitions and controllers, it might make more sense to create our own higher level CRDs, given that it's almost just as easy to create CRDs as Helm values and controllers as Helm templates. I don't see a reason not to do it. We can create our own controllers and often CRDs with tools like kubevela, Crow, Crossplane, and quite a few others. I will not discuss here which one you should use, but jump straight into showing you how that might look like with Crossplane, since that's the one I tend to use. That's a simple user-friendly interface that exposes stuff that matters and hides lower level complexity most people do not care about. It should be self-explanatory what each field represents, so let's just apply it. Now, do you remember how we could not retrieve all the ACK resources we created earlier without specifying each and every single one of them? Well, now we can, since the Crossplane composite resource we just applied acts as a parent that composes children resources, and as a result of all that, we can use something like kubectl tree plugin to retrieve tree-like structure of all children resources of the SQL resource MyDB. There we go. We got the same ACK resources as before, and those in turn are now managing actual AWS resources. The only problem we're having now is that the composite resource SQL has no idea whether the resources it composed are ready or not, since ACK controllers do not provide standard Kubernetes conditions. None of them has the ready status, so the composite resource is getting confused. I could have fixed that by telling Crossplane what to look for, but I was too lazy to do that. You're witnessing procrastination in action. Since Crossplane is not the subject of this video, I'll skip the explanation how I constructed that composite resource definition. If you're interested in taking a closer look, please go to the transcript where you'll find the info where the repository with the source code is. The link is in the description, somewhere there. Typically, I would finish a video with pros and cons. That's not what I will do today, since there is only one positive thing I can say about ACK. It provides Kubernetes custom resource definitions and controllers that allow us to manage AWS resources. That's great, since Kubernetes is the best place to manage resources no matter whether they are running in the same cluster or elsewhere. It is a control plane, so we need something like ACK if some of the resources we are managing are in AWS. Moreover, I cannot imagine a better company to create and maintain Kubernetes AWS controllers than AWS itself. They own their services, so they should own Kubernetes controllers that manage those services. On the negative side, I can only say that almost everything is wrong. ACK has very small AWS coverage. Default reconciliation loop of 10 hours is just silly. There are no aliases like AWS or ACK. There is no easy built-in mechanism to generate secrets. Conditions are all over the place. Events are non-existent, and so on and so forth. I'm not listing cons mainly because there are so many that it's easier to just say that AWS does not take ACK seriously. And that's a shame. That does not mean that we should not manage AWS resources with Kubernetes controllers. We should, since there are much better alternatives to ACK. So don't give up on using Kubernetes as a control plane due to bad experience with ACK. Even if that would be the only option, ACK, Kubernetes as a control plane wins over any other alternative, and ACK is better than nothing. All in all, I'm grateful that ACK exists, but even more grateful that it is not the only option, so I don't have to use it. Now, I suspect that I'm on some kind of a AWS blacklist because of some statements I made in other videos. After this one, my suspicion will turn into near certainty. So there's the message to AWS that I hope will help me avoid being in their list of undesirables. Here's my video version of an open letter. Dear AWS, there are many things you do great. There are many services and projects that lead the way and are shining light in this industry. You are great on so many levels. Nevertheless, ACK is garbage. What pains me is that I know that you can do it well, and I can only conclude that ACK is not your focus. Please change that. Please make ACK great again. I would love to have AWS controllers that are actually good and maintained by you. Until that happens, there is only one place suitable for garbage. And we all know where to put garbage. Thank you for watching. See you in the next one. Cheers.